Hello, right? Okay, let's solve this problem. It's a problem involving normal distribution as an approximation to binomial distribution, right? Okay, let's look at this question. Right? Okay, this question. So medicine M is a type of medicine produced by a researcher can cure a type of eye disease, right? Means that this medicine can cure a type of eye disease with probability of 0.9. Means that the person that taking this medicine, there has a 90% chance of cure the type of the eye disease here, the medicine. So now so this is actually is a binomial distribution here, right? When you read the question, you see there is a 200 people having the same eye disease, right? So means there is a sample. There is a number of sample here. The n here is 200, and the probability of getting can cure is means success, right? Success is 0.9. So there is a probability and there is a number of sample here. So this is a normal binomial distribution, right? And they are independent trial, right? The first patient and the second patient, they are two different person, right? So the first patient, if can cure, doesn't mean that the second person also can cure, right? The eye disease, no. They are independent to each other. So with these three conditions, there is a number of sample, there is a probability, there is a they are independent among all the patients, okay? This is considered as a binomial distribution. But this binomial distribution having a problem now is they're having a very large sample, a very large sample, okay? So you see 0.9, okay, so your NP, your P is 0.9, right? But your value of N here is certainly very big, right? It's 200 people, you know, 200 people. So 200 of them. So you know that from statistical table, this value is already greater than 50, right? It's already greater than 50. So we cannot using statistical table, the table 1, okay, for matriculation. So table 1 we can't use, okay, because 200 very large. So alright, so what we're going to do, right? So we're going to think about it, what we're going to do, right? So I will tell you that we were using the normal approximation. Normal approximation means we approximate it to a continuous, right? From discrete we transform it to a continuous random variable. But actually we cannot doing this. We cannot doing this directly. We want to doing this. That's why we said approximation, right? This is an approximation. We never said exact. It's an approximation, right? There must be a condition. Okay, first you must doing the continuity correction, right? So for the variable x here, the discrete random variable, when you go for continuous random variable, you have to do a CC, the continuity correction, right? So okay, later on, what is the condition, right? Condition, as I tell you before, what is the condition for transforming a binomial distribution into a normal distribution, right? Normal distribution, mean and variance square, right? From discrete to continuous, first you do CC. First your NP must be at least 5, alright? The first condition must be at least 5. So the second condition is the probability. Usually we will take it's better, right? Actually the probability, if nearer to 0.5 the better, right? This one, actually there is a condition. So the larger the n means that if the value of n is very big, or the value of p is very near to the center value here, means that 0.5, right? Very near to 0.5, but it's okay, right? In between here, right? As long as the value of p is in between here and the np is greater than 5, it's already fit the condition, sudah memenuhi syarat, right? But the best is p nearer to 0.5, even better. Never mind, okay? Now you look at this. First, the n is greater than 50, so we consider for normal distribution as a approximation to this distribution. Why? First, you multiply the NP, right? You multiply. So the mean here is NP, right? NP, so you're taking the 200 multiply with 0.9, right? So which you were getting 180, right? You were getting 180. And your variance will be NPQ, NPQ, so you take 200, multiply with 0.9, multiply with 0.1, right? So you were getting 18, right? 18. So you look at the value of mean here. This is the value of NP, right? NP. Is this value larger than 5 or not? It's already larger than 5, right? Must be at least 5, but it's already bigger, a lot bigger than 5, right? So first condition, right, is already fulfilled the first condition. Okay, P, at most you accept 0.9 and 0.1, right? Okay, but this one definitely, if P is nearer to 0.5, is better. For example, 0.49, 0.48, 0.3, 0.6. The nearer to 0.5, the better, right? But doesn't matter, as long as in this range, we accept. 0.9, at this range, so we accept. But the most important is NP lah, must more than 5, alright? Remember that. So, okay, now it's already more than 5, done, alright? So, pass, lulus, kita transform. So, what's your mean? What's your mean? What is your mean? Your mean is 180. So, you put 180 here, right? So, your variance is 18. Alright, okay, now as simple as that, I already explained to you. I have doing the approximation. Okay, now we start to answering the question. Alright, okay, we have clear why we're doing this. So now we're answering the question. Find the value of n, so that the probability that at least n people are cured after the treatment is 0.95. Okay, read carefully. The probability that at least n people are cured is 0.95. So I'm going to write it in mathematical form. So which is probability of at least n people are cured is 0.95, right? So they want you to find the value of n. Okay, very simple. So definitely, because now I have already using the normal approximation. Okay, I already using the normal approximation as, I already using the normal distribution as an approximation for the binomial distribution, right? So we have to do continuity correction. Always remind yourself when you're doing transformation. This is also, you need to do continuity correction. So where I draw a box for this, and this n value, I don't know what's the value, but I know there is an n value, is an integer, so it's n plus 0.5, right? N plus 0.5. You plus with 0.5 and you go backward, you minus with 0.5. Alright, if there is an equal, we always shaded the box, right? Okay, and this is greater. Greater means on the right of the box here, right? So then we do some CC. Okay, the continuity correction is where we're going to rewrite this to become another value here. Now it's not n, right? It's not n. Correction here is, you see the region here, I start shading from where? Start shading from n minus 0.5 and onwards, right? So here the values will be n minus with 0.5. This is the most important that you must do. Alright, I've already repeatedly telling that you must do this. Okay, so now later only you standardize the score. Now only you can start to using the normal distribution. Before you doing correction, you cannot using this. But now after you doing correction, you can using normal distribution. So very simple. So you transform this to z. Okay, you know that if you want to using some normal distribution, you have standardized the score. So it means that n minus 0.5, I have to minus with the mean, the score z, which is x minus with mean over with standard deviation. So the score here minus with the standard deviation, the mean divided by the standard deviation is square root of 18, right? This is variance, right? This is variance. So standard deviation will be square root of 18. So I rewrite this, it will be pz greater or equal n minus with 180. Minus 0.5 minus 180 is 180.5 over with square root of 18, right? Square root of 18. No, now I am finding this. But this everything, after doing correction, this value here is 0.95. They say equal it to 0.95, right? At least n patient are cured is 95%. How to find the value of n here now? So means that this one I have already do correction, it's become this form. So now this is the most important part that you want to evaluate. Okay, pz at least n minus with 180.5 divided by square root of 18, which the setting is 0.95 from the question. Okay, usually I will tell students to writing this as a k, so that I don't need to repeat writing this, it's time consuming. So I let k to be n minus with 180.5 over with square root of 18, right? Okay, let's see how I'm doing this. Alright, so I have already letting k to be this thing to be z greater or equal k, right? Easy to write, okay? So is it compulsory to writing this way? No, okay? This is my way, alright? This is my way, okay? So more than k is 0.95, right? 0.95. So I have to draw the distribution for you so that you understand, right? But actually you learned this before, right? You learned this before in the video under 10.3 for normal distribution. I already explained about this. First you look at the value here, right? You look at this here. Okay, it's greater than. So it's greater than got two possibility. One is greater than k. It's a standard score 0, z, right? Z. So the mean will be 0. So I don't know the value of k. The value of k can be here, right? Or the value of k can be on the right of 0, right? Can be a positive value here. How you want to know, right? How you want to know whether this or this, right? Okay, first you see greater or equal, right? Greater or equal. Greater or equal means that to the right of the k, right? So this is to the right of the k also, but this is a small region because why the probability is less than 0.5, right? 0.5 is half of it. So this is already more than half, right? More than half. This is 0.5, more than half. This is something greater than 0.5, right? So means it's either, okay, there you have two choice, either this one or this one, right? So but you look at the value here. You look at the value here, right? After you look at this one, you know it's either this or this, right? But now you look at the value 0.95. So definitely it's not this, right? It's not this. The k is not this. It's not this. Why? Less than 0.5. This is 0.95. It's bigger than 0.5. So this will be the distribution. Alright? Okay, now see how I'm using this. Alright, okay, now I explain. This is the distribution, right? That fit this. Okay? You cannot simply, okay? You have to look at this. Okay, so now very simple. This is actually, alright, this is just for illustration. You don't go and do this in your exam, okay? Don't do this in your exam. You do on a rough paper, okay? It's for teaching only, okay? Okay, minus with something here, right? Minus with something here. Okay, the whole thing is the whole thing, right? The whole thing, everything here, the whole thing here. Semua is 1, right? Is 1, right? Minus away the small part here. Can you see the section here? Minus the small part here. The small part here is minus away this one. This tail here, right? This tail here. This is k, right? But from statistical table, we never study about the. We don't have a value for the left hand tail, right? So we have to write this. We have to convert this into a right hand tail, or we reflect, right? We're using reflection because normal distribution, they are always symmetry about the line 0, right? So okay, so this is the same as I rewrite this one into the upper tail, right? The right hand tail here. But if here is k, if you're going that side, no longer k, right? You shouldn't write k. How come they have the same value, right? Logic, right? Common sense. You put k here, here cannot be k, right? So this is a negative side, right? This is a region less than 0. So k is a negative number. So a negative number, 1 to become a positive number, satu nombor yang negatif dan negatif nak jadi positif mesti dah letak negatif depan. Right? Contohnya negatif 2. Macam mana negatif 2 nak jadi positif? pergilah darab negatif 2 itu depan itu dengan negatif, it become positive lah. That's why I put a negative k here, because now it has to become positive, because it's only on the right hand side, right? It's on the right of 0, it will be positive. Okay, you must have this knowledge, you know, you must have this knowledge. So okay, let's see how to using this. All right, okay, now we know that Pz more than k equals 0.95. After I illustrate you, this is the meaning of Pz more than k, more or equal k, and 0.95. The area now is 0.95, right? So it's the same as you taking 1 minus away this one, and this one is the same as this one, right? The area will be the same, right? So means that I can rewrite this into, this one is actually Pz greater or equal k for this case, right? For this case, so it's 1 minus Pz greater or equal negative k, right? So I can rewrite this after this is the same as this one, right? It's the same. So you have to write at 1 minus Pz greater or equal negative k equals to 0.95, right? So then you know that Pz greater or equal negative k will be 1 minus 0.95, you're getting 0.05, right? So you can find this value from your statistical table. But for this value, I have teach you before. In the previous lesson. So when you look at the value here, it's very beautiful, right? It's 0.05. Usually we were using the table 4, okay, the percentage point, right, which is on the last page of your statistical table. Which is 0.05. See that the alpha 0.05, which is compared to the corresponding to the score Z 1.6449, right? 1.6449 means that the negative k is 1.6449. So finally you have find the value of k, which is negative 1.6449. But what we want is the value of n, right? It's the value of n, right? So then from here I continue k. I replace back the k, right? If I never write k, if I never write this to be k, I need to repeat writing this, right? Not smart, right? Okay. So then I have n minus 180.5 over with square root of 18. K is equals to negative 1.6449. So if you multiply this, you will getting n equals to this one multiply, and this one go there, become 180.5 minus with square root of 18 multiply with negative 1.6449. Alright, so the n is in decimal form, okay. So they were giving you the value of 173.52, right? 173.52. But you must remember, what is n? N represent the number of people, right? Number of people, right? Number of people. So for example, you look at this question, right? The value of n here, at least n people, right? How can you say that at least 173.5 people? Okay, how can you say 1.5 people? What is the 0.5 here, right? Meaningless, right? So very easy. If you have this type of problem, very simple. Just round off to the nearest integer, right? Round off. So you just round off. Don't need to overthinking for your level, right? For your matriculation level, don't overthinking. Just do, because this is just an estimation. Remember the word of estimation. Once you understand the meaning of estimation, then you don't talk about y must be 173, 1 must be 174. No, okay? Because estimation, we just estimate, right? Probability, decision making. So n is around, after round off, I round off to the nearest integer is 174, okay? 174 means that the value of n is 174, okay? So some of you may say, sir, can I take 173, right? Can I take 173? Also can lah, okay? It's estimation, okay? That's why I tell you estimation, alright? You estimate only one people or more than one people or less than one people, doesn't matter. Because why? The sample is very big, you know. We study about we study about something very big, 2,000, maybe 500. Do we care about 1 or 2%, right? No. Okay, that's the way I'm telling you. Okay, some book may give you 173, some book may give you 174. Remember the word estimation. All right, so n is 174. All right, that's all for this video.